Hello, my name is John Strablow. I am the Principal Product Manager for the eventing service here at Couchbase. I've been with Couchbase for about 15 months and I'm razor focused on all things eventing. So we're going to go through a recap of basic eventing and what it is. Then we'll go through the building blocks of eventing, where we use JavaScript to react to mutations or changes in data. And then we'll go over a real world eventing function, and then we'll get into some advanced eventing functions that will introduce you to some of the possibilities of using the eventing service. So, a recap of what eventing is. Why do we do eventing in Couchbase? It's akin to triggers that you might find in an Oracle database. The key thing is that we centralize your business logic, and it's co-located with your core data service, okay? And actions are taken in real time in response to changes in your data, or in Couchbase's parlance, mutations. It's highly available, it's performant, and it's scalable both vertically and horizontally. It can handle high volume mutations, hundreds of thousands, if not millions of seconds in real time in large clusters. It makes it easy for you to develop, deploy, debug, and maintain data-driven business logic via a centralized platform. And you don't have any concern for infrastructure. It's infrastructureless logic, okay? And it's part of the Couchbase data platform. No third-party license. You get an EE edition license and it's included. You don't need any additional data ops skills to manage the additional stuff. All said and done, you develop, you deploy, and you manage dynamic data-driven business logic without infrastructure. That's what eventing is written to do. It's a service that allows you to do more with change. So here we have 4 applications up north, and then we have some things that could be consumers interacting with Couchbase data. It could be like a Kafka queue, it could be another database, it could be a REST API endpoint, or it could be Couchbase's SDKs where you write other applications. So when we talk about eventing, it's real-time server-side processing. Easy to develop, deploy, and maintain. It's highly available and performant and scalable. We bring data-driven business logic closer to the data, triggered when data changes or mutates. And we have native integrations. Eventing can talk to the data service, and we call that KV integration. Eventing can talk NCL, which is our SQL plus for JSON, and that can be directly embedded in eventing. Eventing can talk to a REST endpoint via curl integration. It's either your gets or posts. And eventing can output to the function's application log. So think of a Lambda. Every Lambda has its own log. You could output your log. Some customers might put Splunk and attach it to every eventing node's log. And so it really is a native integration. It is something that eventing deals with, interacting with the outside world. You can enrich or alter content in near real time. You can trigger routines at specified intervals. And you can propagate changes to other systems via the native integrations. So you actually see a document that just flowed through from the shipping app into the Couchbase server. There's a mutation. It hit an eventing function, and then it changed something in the Couchbase server, and it set a timer. And then it talked to the REST API, an outbound thing through curl. That timer might fire off seconds in the future, minutes, or perhaps a day. But when the timer fires off, it uses a context that was stored with it, and it can do stuff, and it can change the database again, or it could set up another timer. So pictorially, that's what eventing does. And it's not just one function. You can have 30 functions. Most customers are under 15 functions, or they have 2 or 3, or they use eventing as a toolkit. But we do support a large number of functions. Now, to understand eventing, it would be very good to go through the building blocks. So these are kind of the building blocks, the basic bucket ops, how we use nickel, how we can use nickel as a function for more performance, a prepared statement, how to use curl for gets and posts. So here's the basic eventing data service integration. These are your basic bucket ops. The on update is an entry point. So every mutation in the source bucket that you're listening to will actually call this entry point, which is just a JavaScript function. And then typically a user will filter out and only look at what they want to see. And then assuming we get past that gate, we can log. So that's writing to the application log. Here we're writing the key, which is meta.id, and we're also writing the document that we received. Now, we can do some stuff in normal JavaScript. We can modify the document, make a new document, and that's exactly what we're doing here. We're making a new document, and we're putting the old document as a subdocument called mutation and sticking on a silly status with a number. And now, we can do a set operation or write to the bucket for the KV service. We can do a get operation, read what we just wrote, and then we can delete. We can delete what we just wrote. So these are the basic operations that you will find in eventing. Okay, so we're going to do a quick review of basic bucket ops. And in order to do this, I've set up 3 buckets: a source bucket for mutations and a destination bucket where we'll write one item and we'll end up deleting it. And metadata is a scratch pad used for eventing, and it can be used across multiple eventing functions as a best practice. So with these 3 buckets, we are going to import the eventing function that we just saw. It'll save some typing. And once the function's imported, we'll see the source, the metadata bucket, a function name, and most importantly, we have a bucket alias. This allows portability in functions, and we have an alias of DST_BKT for destination bucket. That's the real bucket destination, and it's in a read-write mode. This is the code that we just saw in the main presentation, and that's really all that we really need. So we go back to eventing, we will deploy this function, and we'll deploy from everything. This will allow us to pick up the one item that we have in documents, very simple item, and it will match the filter in our eventing function. So when our eventing function is fully deployed, the filter will be matched. We have one item that was a success. There were no failures or timeouts. And we can view the log, or we could go down into the file system and we can take a look at what we did. The very first log message was, hey, we've got a mutation. It was either an insert or an upsert, update, or document creation. And there was a document. That document was used to create a new document that was nested. We just changed the name of doc to mutation, nested the same information. We wrote it out into the destination bucket. We read it back, print it out. Yeah, it looks the same. Then we went ahead and deleted it. And since we deleted it, over in our buckets, we'll see the destination bucket is still empty. Okay, the next set of eventing integrations that we're going to talk about is Nickel. Nickel is SQL that's been enhanced to work with JSON. It's a very powerful language, and it can be embedded directly into eventing. So let's go there. Now we'll look at an example of an embedded nickel statement. Here we have two buckets, our tried and true travel sample data set that there are a lot of examples done with, and a metadata bucket. So we need nothing more as far as the data is concerned. We're going to import our simple function, travel sample metadata, name. Don't need any bindings for this example because we'll be using nickel. And there's our code. It's a fairly simplistic function, but the important thing is that here we have an interesting, just embedded nickel right in the middle of our JavaScript code. So let's deploy this. And when we deploy it, we're going to deploy from a feed boundary from now, because we don't want to process every single route or airline, whatever our filter was set to. So this will deploy and then nothing will happen. It'll be all zeros or all balls under the statistics. And we're going to have to go into either documents or nickel query and update something, okay? I'm going to update airline 10, and just I'm going to add another field. We'll call it, fascinating name there, dummy is true. Okay, we save that, go back to our eventing function, and because we triggered an airline, we matched our filter. If we look back in here, that's our filter. Don't process anything that's not an airline. And so what did we get in our log file? We've got something interesting in there. We can't see it too well, so why don't I just take a look down here. So airline 10 had two, it had a name of Q5, it had a route count of 2. This would have covered a lot more airlines if we had done deploy from everything for our feed boundary. But this is just an example to get people focused. Okay, so now we're going to go over dynamic SQL using a prepared statement. Okay, so now we're going to do dynamic SQL and positional parameters. And this will be almost identical to the last demonstration, same buckets. However, the function is going to be slightly different. And we're going to prepare the statement for performance when we run it. By default, we usually have 3 workers. I set this to 12. It'll run a little faster. And as you can see, this is really a string that we're giving. And the $ number is a positional parameter that we pass as an array. And I tell Nickel that I want this to be a prepared statement to be more performant. Now, one of the things I do want to point out, even though it is more performant, we will be using Nickel, and I'm going to deploy intentionally from everything here. And because we're using Nickel, it's not as fast as a direct key value fetch from the data service. There's times when we want to use Nickel, and there's times when we don't. You'll see that when this deploys, and it will start doing, that's essentially not really a query count because we are filtering. I think we do about 1,800 or so Nickel queries, all said and done across the 31,000 or so items in this sample set. But needless to say, we are doing a lot of queries, and when we're complete, which we are almost done, and it should be it. As you can see, we now have some counts. Some airlines have no routes. Some airlines have 12 routes. This particular airline had 28. Here's an airline that had 340. The next integration is with external REST endpoints, and this is done through curl, which is built in to eventing. We're going to initially go over get, and then we'll go over post. Okay, so now what we're going to do is we're going to review a quick curl get. Two buckets, source and metadata. We will import our function as is what we've been doing. The most important thing is that we have a binding of a URL alias. So the alias we use to contact the REST API is some name we give it, and that's known in the JavaScript. And we have an actual URL. Different sort of authorizations that we can apply, but there's no auth required for this. And the function itself will just go out and make a get, and it will print either fail or success and print the response body. So let's go ahead and we'll deploy this. It'll take about 18 seconds, and when it gets done, we'll end up with a list of exchange rates relative to the euro. So you can imagine the usefulness of applying to a stock portfolio in daily exchange rates to calculate P&Ls. Fairly long there, but you can see some of the rates like the Canadian dollar. And maybe if we just take a look at, we see a little bit better down there in the corner. The euro is the base rate. That's always going to be unity or 1. The New Zealand dollar, 1.7. Great Britain pound, 0.91. Now that you've seen how get worked, grabbing the exchange rates from a public REST endpoint, we'll demo post, and this one will be using another public REST endpoint for echoing things. Okay, similar to the curl get, we're going to do a curl post. We're going to have the same trigger document. Remember, it's very simplistic. We're just keying off exactly what the key is. So let's go ahead and take a look at what we've got going here. This will be our function and a slightly different endpoint. Add the code. This particular REST endpoint is just an echo API. We send it something, we get back something. And as you can see, what I'm posting is a fairly simplistic body, my Boolean true. That's what I expect to get back when this all works. So we'll deploy that from everything. So we pick up a mutation. Using, these two examples should allow you to write your own curl IO to REST APIs. Once again, it's fairly long. We can look there, but the key thing is it did echo back what we sent it. Okay, on to a real-world function now that we've reviewed every major construct except timers. We'll get to those later. We're going to be doing redact shared data. So essentially, this small function will pick a portion of a master profile and share it with a business partner. On to the demo. So here we have 1 million documents, and this is a master profile, and the function is going to whittle down the master profile, strip out sensitive data like Social Security and credit card information. So in order to show how all this works, we obviously have to load our venting function, And in our inventing function, we have set the number of workers to 12 for performance reasons. We have a bucket alias of AWS bucket to a real bucket called destination, and it's in read or write mode. The code is fairly small, and it just picks out the stuff that we want to share with our business partner that has a Couchbase server in the cloud. We're going to deploy this, and I want you to pay attention to the performance. This will take about 12 seconds after the function is fully deployed. And remember, this is a very small server. It only has 12 cores, and it's one box, and it runs everything on the same box. So it's about ready to start up. We're already about 1/4 done, about 1/2 done, about 3/4 done. And we have 1 million shared profiles that are created in another bucket called destination. We take a look at our documents, and as you can see, it's a much whittled down profile. Master profile is now shared profile. Once everything is in place, what I'm going to do is I'm going to take a I'm going to create an index just so that I can do something. I'm going to mutate 10,000 documents. And when I mutate these documents, I also want to see how long it's going to take. Under 651 on, we can pause an eventing function and edit it. And it just puts a little placeholder right where you were. And I want to do some timing. I want to prove just how fast eventing is. Okay, I'm just going to simple, a log statement. I'm going to save that, and we will resume the function. And remember, I just made an index. The reason why I made an index was so that I could run a query function to mutate 10,000 documents. So when this gets deployed, we'll see that we picked up where we left off. There were no mutations. So we're going to take a look at our log file, completely empty, but we will log a message for new mutations. So I want to show you with 2 windows exactly what's going on. So we're going to go to the query editor here, and I have something in here that will actually take 10,000 keys, offset it, whatever I want to offset, doesn't really matter. I could offset, 500,000, 300. And that's the way we're going to mutate our documents. So I'm just going to execute this. This will take about 3 seconds. And this is what nickel takes. So 2.7 seconds. Nickel took that. You saw we're already done. And in our log file, we have 10,000 lines as expected. And how long did this really take? Let's see, it took 2.7 seconds. So eventing was keeping up with what nickel is. Eventing can run much faster. So what I really wanted to show you is that even though we took 12 seconds to load 1 million profiles, okay, when things change in real time, we're updating things in eventing in real time. Okay, the next function is a fix emails domain function. And for this, we're going to go straight to the website. In fact, almost all the functions that I'm going to show today are on the website, so you can follow through yourself. We read the little terse instructions. This is a terse scriptlet, and we see that there's one important thing here. We have to make an alias in mode read write. So what I'm going to do is I'm just going to copy the function. We're going to go in, and I have a source bucket, metadata bucket. They're empty. Go to eventing. We're going to add a function, and it will be source. And we have our scratch pad that can be shared among other functions. And we are going to do fix email addresses. And we need one binding. That was the key thing. src bkt, and it will be bound to the real bucket source in read write mode. Now, we had copied our function. The top half of this is a sort of a regex that I wrote, standard JavaScript. It takes a document, a field name that you want to update, and the final email domain name you want to simplify things to. So over here, we make sure we only operate on employees, type documents of employees. And we're going to normalize that email address to my company's name, which is bigmovies.com. And there'll be some logging messages. Very good. We need to save our function. And then we go back to eventing, and let's just go ahead and deploy it. And while it's deploying, it takes the 12 to 18 seconds. Let's take a peek at the input data mutation, key employees 101. Okay, it has to be a key to be read. And we're going to go back to our buckets, documents, just add a document of the example key. Could have been employees 202. But the key thing is the data needed to have a type employees. Okay. And pay detailed right there. The email address is wrong. It has a sub host in there, at mailhost.bigmovies.com. We might have mailhost 1, mailhost 2, mailhost 3. And the idea was to normalize all our email addresses in our company. So I'm going to go ahead and save this. Oh, gee, something interesting. Wait, didn't this say at mailhost@bigmovies.com? It sure did. Well, let's go another host. So eventing reacts, oh, I misspelled host, not that it matters because it will strip it out. Save it. Eventing is acting in real time, okay? And it's doing what we expect in real time. It's fixing our data for us. So if you think about it, you could basically use eventing to set up 2 different versions of your apps and 2 different versions of your database as kind of the glue to make sure everything was working as you roll them out. So we should have some log messages in here on updated. Oh yeah, we changed something to what we expected. And since we did it twice, we have 2 success messages. Now, back to our main documentation page, scriptlets has the expected input data and has the expected output data. So as you can see, we ran through this very quickly. Everything was very nice and it was easy to do. This next function is to keep the last n items. The mutations of some sort of data will come in and we'll keep an array of information. We need our source bucket and we'll have to make an alias to that and read write. All the directions and instructions are tersely laid out here. I'm just going to copy the function and we'll go back. We will go to our eventing page. We're going to add a function, source bucket, our metadata bucket, and keep the last n. Binding type, very important. And once again, it will be src, bkt. We'll go to a real bucket and in read write mode. Highlight the template, overwrite it, save our document, and let's deploy it. There's no documents in the source bucket right now, so it'll deploy, but there will be no mutations processed. Let's get our input data. And we do this a little differently. We're going to use the query editor to create 10 items. And one of the things that I'd like to point out is that there's really 2 different things that we're going to be keeping a track on. So we've got these items with subkeys 1 and 2, which means we're going to keep the last 3 on what that little suffix is on 1 or 2. So if I look at this, the last 3 things should be a 7, a 9, and 10 for that suffix of 2. And the last 3 things should be 8, 5, and 4. I'm just going to execute that immediately. Eventing goes to town. It does the processing that we expect. And we have 10 mutations. Let's take a look at what our document set is now. We have 12 documents. Be careful if you come in with 10, you wouldn't see these 2 things. So we had these 10 things, but I wanted to keep a document that holds the last three of each of those suffixes. And this is indeed exactly what's happening. If we go back to the scriptlets where we talk about what the function is, what it does, an input data set, and our expected output data set. And sure enough, 4, 5, and 8, and 7, 9, and 10 were exactly what we saw. This next demo is an example of a shipping notifier. It will need a metadata bucket and 3 additional buckets that need to be set up accordingly. It operates on a type document ship. It'll update the source document with key information on each notification. And once the delivered item is delivered, the shipping record itself that stores everything about it is archived. And it's a fairly complex function. You can copy it, paste it in, set up the buckets as you were instructed. I, unfortunately, am going to save a little bit of time, and I'm just going to import a function, and we'll get that in there. And all this did is it just set up the source metadata, and it set up the aliases the way it should. And I didn't have to copy and paste the code because I had imported it. There's some information about what will go on, a lot of documentation in the top of the function so that you can understand what will go on. And I'm going to walk through this, and we're going to first just deploy our function. Then we'll go back to the scriptlet and we'll get the input data mutation. And this is going to set things up in the past, just so that you know if you don't want it in the past, you can change the Unix timestamps to be like 10 minutes in the future and then watch it fire off, or be like 2 days in the future, or a week. So we're going to use the query workbench, and I already have what the copy paste in here. We're going to just execute that and go back to our buckets and see what happened. It made 3 documents, and it probably set up a timer, and we have to wait about 7 seconds. Timers they work with volumes. There it went. And so the very first notification, this could have been a curl notification, or it could have been something to another bucket, or it could have been picked up by the Couchbase Kafka connector. But essentially it just said, hey, this is scheduled for delivery, and it had some information about the email address and phone number. So you could do both an email and an SMS. And it has a scheduled delivery time, which might be, some time tonight. Well, since this was in the past, it's just running faster for us. So with that first notification out, let's take a look at the shipping record. We have 3 documents in here, and we have an order. Okay, the guy ordered some pencils and some Sharpie. We have a customer, and we have a shipping record. Okay, so the shipping record is active. It hasn't been delivered yet. It hasn't been shipped yet. But let's say we were using FedEx, UPS, or the United States Postal Service, and we find out that it's been shipped. So something would update this record, and that could be any of Couchbase's SDKs. Once this record's updated, we can do this, and immediately the shipping record will have picked up another item in an array of notifies when it was actually shipped. And as you can see, we are now in Unix Epic in the 1.6 series. So even though this was in the past, we said it was shipped, and boom, the customer gets a notification that it was shipped. And sure enough, if we go to the bucket notify, we will now have 2 notifications. The second notification, notify:1, says that it was shipped out. Now, the last thing that happens is, say it's delivered. So your shipping vendor or partner will give you some information that, hey, something's been delivered, and we we'll set delivered to true. If I can find where that is, here it is. Now, the code was written that if there was no timestamp passed, it will use the current timestamp of the notification. Or if the timestamp's in there, it wouldn't override it. But if I save this and we go back in to our buckets, it'll be very interesting because we no longer have the shipping record. The shipping record self-archived, okay? So the shipping record will be in the archive, and that will include a complete history of kind of what happened. It was scheduled, and for some reason, since that was a month in the past or something like that, it shipped, and that's current time. And then I said it delivered, okay? So we have a history, and that's been moved outside of our active bucket, so to speak. And we have 3 notifies. And the 3 notifies would be, hey, you're scheduled for delivery sometime today or tonight. Then it was shipped, and then, oh, guess what? You received the document. And the way this scheduled for delivery was written in the eventing function was that when you set up the shipping record, the delivery schedule was for that target day. So it was like the morning of when you expected your item to arrive. And once again, this is all in the eventing documents, and there's great amount of detail on this particular function about, hey, what happens, how long you should wait, what you will see, and then what it is that you'll have to change. And it goes on and on and on. So if you don't have to watch this video, you can kind of walk through this a little bit more. And this is a sample of just one of the use cases that you can, an advanced use case that eventing is totally qualified to do. Okay, so the last detailed function that I'll show is a date to Unix timestamp conversion function. And the unique thing about this, it's generic. It doesn't care about your data schema or what the fields names are. It can discover string dates based on pattern matching and turn them into a much more compact numeric form. So over in here in this section on our documents, we've got several functions that are very similar. I mean, they can remove nulls and empties and further compression your documents, or they can rename long fields to short fields. But right now, we're going to just focus on the first item here. The function itself will only operate on a particular data type, and we will need an alias of, to our source bucket. Let's take a look at it. It's not that long. It could look a little daunting, but it is JavaScript. When we go into the on update, we will be matching certain things, and we'll be converting something to a millisecond stamp or a second stamp. And sometimes we'll rename things, and we'll put an underscore ms or an underscore second, and it's all documented in the function itself on how it converts things. So we're just going to go ahead and copy that JavaScript, and let's make ourselves a function. So add function, and we're going to have a source bucket. We're going to have a metadata bucket, and this will be date to epic conversion. We need a binding, and that will be a bucket alias of src_bkt. Yes, source bucket, and it has to be read-write because we are going to be changing our documentation. So what we just copied there, paste it, make sure we save our function, and we go back to eventing, and let's go ahead and deploy it. So we have a source document that's already in there, and before it deploys, let's take a look at it. I basically cut and pasted right here from the input, and as soon as our document is deployed, these items will change. Some will get underscore ms or underscore sec put under them because we recognize that these are dates. So close that, and we hit retrieve documents, and voila. We've actually compressed our data set in a very generic fashion. So there are several functions that are in this class of generic items. So for instance, remove nulls and empties. I'm not going to run a demo on this, but here is a deeply nested document sample. As you can see, it has empties, it has nulls, and I want to clean up my document. I don't want any of these things that are empty objects or null properties. So if we actually run this function, it will clean things up. That's your input and output. So I challenge you to walk through all these examples. Say I want to rename a very, very long name, okay, to a shorter name. And I have a set of names I want to rename across millions of documents. Make a small map, and in this function, and I just apply this as a one-off tool. So we have all these long names. There's one super long thing that I'm not going to change, and we run it, and it will shorten things up for you. So you can get some significant space savings doing things like this. And then probably the last thing I'll show you, generic flattening. I don't know why you'd want to do this, but let's say you had a deeply nested set of data and I want to flatten it out. Well, this particular function will flatten it out into something that, say, an RDBMS could import, because now it's flat, or you can export it to CSV. So real powerful stuff, and really, it's been fun introducing it to you, and I highly recommend you go to eventing, the current documentation set, eventing, and go to our examples. Once you get through 2 or 3 of the step-by-step examples, which are highly detailed, you'll know enough to work through these scriptlets or terse examples, which I introduced today in this virtual seminar. All right, so we're almost at the end of my time, but I did promise that I would show a little bit about venting timers. We use them in the shipping notifier, but for this, we'll take a quick peek at the document set. There is an example called recurring timer, which is a step-by-step example. So it's quite detailed. It talks about the buckets you set up, how to set up a test document, and every step of the way pushing the buttons. So with that said, you're more than free to walk through that example, but we will just import a function that I've already got existing, and that will come in source bucket, metadata bucket, function name, our bucket alias, and our recurring timer code. The important thing about this code, it's not excessively complex, but what I want you to understand is that on update, we're actually testing a document to see if we want an active timer or not. And if we do, we keep the timer active. If not, we just don't rearm it, and technically it's canceled, okay? So we can create our timers and we can override our timers in 6.6. They're very robust and you can set them in the future, but we're going to get something that happens every 30 seconds. And I just wanted to, talk about that. We're going to create our recurring timer if we're not, if we're active, okay? And we're just basing this off of a little document, and the recurring timer gets made, and it can also get made by the callback. And this is a great improvement in 6.6, is that you can have recurring timers, and it'll just be setting every 30 seconds. Now, one thing about timers, they're high volume. So you can do hundreds of thousands, millions of timers, but they're not wall clock accurate. There's a scanner every 7 seconds that picks up timers that are waiting to be fired. So don't expect 2 to 3 second granularity. It's really pretty much a quarter of a minute or longer that you should be setting your timers for. So I've already set up a control document. As you can see, the activity is false. So let's go ahead and we'll deploy this function. And I deployed from everything, and we're going to actually, I want to get a little bit more room on that. And when it deploys, we should be able to just see what's happening, okay? And let's do a tail minus F. All right, so let's go back to our documents and turn on the timer, and that will be a mutation, okay? So this is a control document that we've set up that just will run a timer. So let's just say true. This document has been mutated, and oh, look, on update, we've got a recurring timer. Active was true. We've recreated it. So in about 30 seconds, this will trigger, and so the same sort of information, of course, will be coming to the log reverse order. The nice thing about the UI log is that it merges all the nodes into a single unified view. And that's a good thing. When you run on one node, you can tail something in the file system, but when you have multiple nodes, not so straightforward. You'd have to tail multiple systems. And there was the first 30 seconds. The timer fired, it did what it wanted to do, and we won't see any more mutations because this is happening in timer space. Now, one of the things about timers is we're waiting for yet another one. This function would have had 2048, not function, I'm sorry, bucket, 2048. When you add timers to a function, you have a little bit more metadata. And then you have approximately 3 docs to, 2 docs because there's some housekeeping documents, but you can look at it as like 2 to 3 docs per timer. And that would go back down to 2048, 2 documents per vbucket. Or on the Mac, it would go down to 128 because Macintosh only has 64 vbuckets. But very good. We just showed you how this works. Now let's turn off our timer, and this will demo a cancel timer. So we make that false, we save it, and we see we have canceled our timer. And that concludes my time. That includes this presentation. I hope this has given you some ideas about how eventing can be used, and feel free to walk through all the examples on the documentation site.